Alright, so let's start with our warm-up for today. Sasha the Siamese cat weighs 13 pounds. Phoenix the Maine Coon cat weighs 21 pounds. Are either cat at an unhealthy weight? So think about your past experiences with cats. Think about how they compare to each other. Anything else you might know. And just think, if you were a vet, what do you think? Well, you might be like, there's not enough information in this question. I don't know anything about either of these types of cats. I don't know what a healthy weight for just cats in general is, maybe. So you need some more information. So what I'm going to tell you is that both of these cats, their weight follows a normal distribution. For the Siamese cat, it follows a distribution, and I'm using a new kind of terminology or notation here for this. So what this means is the mean is equal to 8 pounds. And the standard deviation is equal to 1.9 pounds. So this is just a more concise way of representing a normal distribution. For the Mancoon cats, it has a mean of 17 pounds and a standard deviation of 2.4 pounds. Okay, so what I can tell you just based on that information, and hopefully you can kind of get the same information as well, that Mancoon cats are quite large in comparison to Siamese cats. Siamese cats are generally quite small. So even though Sasha is quite a bit smaller than the Mancoon Phoenix, it doesn't necessarily mean that either of them are at an unhealthy weight. Okay? In order to figure out if they are unhealthy, we want to compare them to the rest of the cats that are the same type. So we want to compare them to the distribution. And we've actually done that already. In the statistics unit, we compared to monkeys. Again, different types of monkeys, and we compared them to the overall distribution of that particular monkey. Now we're going to do the same thing for this. So in order to compare them, what we did was we used a Z-score. So just remembering back to what a Z-score formula was, it was X minus the mean, so how far away your data point is from the mean or the center of your deviation, divided by standard deviation. It's divided by the standard deviation to tell you how many standard deviations it is away. Because if you have a much more spread out distribution, then maybe being 10 units away is not as big of a deal. Whereas if you have a situation that's, or distribution that's much more clustered, if you're, say, 10 away, that might be a big deal. You might be really far away from the majority of the data. It kind of depends on, like, almost what your scale is. You want to normalize the scales. So that's what we're doing when we're doing a Z-score. So for the Z-score for Sasha, and you should pause this and try and calculate these on your own and then come back. Okay, hopefully you're back. So the Z-score for Sasha is the X value for Sasha, so Sasha's weight, minus the mean value for all Siamese cats, divided by the standard deviation for all Siamese cats. So Sasha's weight was 13 pounds, minus, now that kind of looks like 131, so I'm just going to put cursive there, minus the mean for all Siamese cats was 8 pounds, divided by the standard deviation for all Siamese cats, which was 1.9. So now what happens when we do the subtraction on the top? Again, order of operations. You can do this all on your calculator at once, but you got to make sure that you are first working at the top and then pressing equals before you divide, or putting parentheses around your numerator. Either way would be fine. But so you end up getting 13 minus 8, which is 5, divided by the 1.9, which gets you 2.63. And numerator will be pounds, denominator will be pounds. So it ends up being an actual unitless measure. Okay, what it means is that Sasha is 2.63 standard deviations above the mean. I know it's above because it's positive. Okay, so now if we look at the Mancoon Phoenix, his Z-score is going to equal his position, his value, minus the mean for all Mancoon cats, divided by the standard deviation for all Mancoon cats. So his weight was 21 pounds. I'm just going to leave the units out for this one because we've already determined that it is a unitless measure. And when we end up doing the division there, we get 1.67. Again, if you're not getting the same answers as me, it's because you are not doing the numerator first and then separately doing the denominator. What you're actually doing, in essence, is you're doing 21 minus 17 divided by 2.4, which is obviously very different. So in your calculator, you either want to put some brackets around there, or you want to just press equals after you do the subtraction, and then do that. So moving on, we can also take a look at the graphs of both of these normal distributions. So in order to graph, we need to figure out that plus or minus 3 standard deviations, like we did in the last lecture. So when I'm calculating plus or minus 3 standard deviations for the Siamese distribution, we'll get between 2.3 and 13.7. So I've plotted both of those points. For the Maine Coon cats, we will get between 9.8 and 24.2. So I plotted those points. I haven't drawn the curves yet because we can kind of look at these points as well to determine which one's going to be highest. The red values for the Siamese cats are closer together. So it's going to be a higher peak than the blue because the blue is more spread out. So that's just kind of another way of thinking about it. So plotting the two means, we have a mean at 8 pounds and a mean at 17 pounds. And then we can draw our nice smooth curve through those. Again, yours don't have to be perfect, but they should be nice and smooth and be a curve. If we want to now look at where each individual cat is in that particular distribution, for Sasha, she's way down here, really close to that kind of 3 standard deviation mark. So there's not very many Siamese cats that are actually way more than her. The majority of the population of Siamese cats are below. For the Maine Coon cat, Phoenix, his data point of 17 pounds ends up falling on that line. So you can see he's still, in terms of weights and comparison, he is overweight, but maybe he's close enough into the distribution that it's not considered at risk overweight. So again, kind of the veterinarians would have to do some studies and figure out at what point do we consider this overweight, a risk to their health, and all of that different things. Okay, so again, today's lesson is normal distributions, part 2, and we now have this new way of writing the normal distribution with the mean and then standard deviation squared. And we always write it as standard deviation with the squared. We don't actually calculate the square value and then write just a number. We just leave it like that. That is the accepted notation. So we had this graph drawn from last class. Now all I'm going to do is I'm going to add another line below it. Again, you should use a ruler in your notes. And that's going to be for our z-score. So when we're at the mean, we are 0 standard deviations away from the mean. When we are at mean plus 1 standard deviation, we're 1 standard deviation, 2 standard deviations, 3 standard deviations. And similarly going backwards, but negative. Okay? So now the curve, if it's located on the z-score, that's called the standard normal distribution. And that has a normal distribution of 0 for the mean and 1 for the standard deviation. Okay? So now if we take a look at what we can use that for, now we can actually refer to this big chart. So it's in the back of your textbook, page 606. It's also on the back of your formula sheet. You can also just Google it, z-score chart. What this is going to tell us is it's going to give us the probabilities for values that aren't in that 68. Like if we go back here, we were using the 6895 values last class, but we didn't look at anything that wasn't a whole number of standard deviations away. We only looked at 1 standard deviation away or 2 standard deviations away, and then we were able to use those key numbers to calculate. But the cats, for example, Sasha was somewhere in here, right? And Phoenix was somewhere in here. So how would we calculate the probabilities related to those values since they're not right on one of these vertical lines? That's where this chart comes into play. Okay, so this is how we're going to read the chart. So again, remembering that this is a normal distribution with standard deviation with a mean of 1 and a standard deviation of 0. And what it's showing, as you can see in the two diagrams, is it's always showing the area to the left. Again, remembering that area is the probability. Area under the curve is probability. So it's saying that whatever number you're going to look up on this chart, it's the probability of randomly selecting something below. that particular z-score value. Or it's the, yeah, well, that sounds good. Okay, so how do I read this chart? So let's say I wanted to do a z-score of 1.67, for example. So if I want to do 1.67, I'm going to look on the positive side. So all these z's are positive. I'm going to go down this chart until I get to 1.6. And then I need to go over to get the other decimal value. So how far over do I go? Well, 1.7 is there. So I need to go over to that column. And then that number. So that's telling me 0.9525, or 95.25% of the information is below 1.67. Okay, so let's practice using this a little bit more. Let's use this chart to confirm that 68% of the data is within plus or minus 1 standard deviation. Again, remember, that's what we said on this chart back here. We said this section had 68% of the data. So now let's use that to try and figure it out. Okay, well, the two key numbers that we want to look at are a z of 1 and a z of -1. So let's look up those numbers in the chart and let's interpret what they mean. Okay, so if we're going to look up a z of, let's go with -1 first because it's on the left. So if we go to -1, that means we're looking down the z-score chart until we get to -1.0. And then I don't actually want any more decimal values, so I want 0, 0. So I'm just going to select the first one in there. So the probability that z is less than -1 is 15.87. So if we were to shade that area in on this graph, it's going to be in there. Basically what I'm saying is this area is 0.1587. So you can interpret it as the probability of selecting something, the percentage of the population that's in there, all of that kind of stuff. Looking at the next one, if we're going to +1, so here again, this 0.8413, we would get it the same way. We'd look down this column, go down to 1, and then I want 0, so I'm not going over. I'm just going over to the very first one. I'm not going over anymore. 0.8413. Again, if we want to look at what that means in terms of what it's going to look like on the graph or the curve, it represents this area. So again, that area is equal to this 0.8413. Okay, so now how can we use those two areas to figure out the kind of in between 1 and 2? Well, let's put this stuff together. So we've got the orange, we've got the blue on top. What we want is the green. So how can we work that out? Okay, well, if we know this, which we do, and then we subtract this, what we should be left with is the green. Okay, so that's what we're going to try and calculate. So I'm going to express this in terms of mathematical notation now. We want to find the probability that z is greater than -1, right? It's to this side of -1, and less than +1, this side of +1. So in order to do that, what I'm going to do is I'm going to use the orange and blue. So the orange was the bigger one, and the orange represented the probability that z was less than +1. And then I'm going to subtract from that the smaller, which was the blue, which is z is less than -1. Now this kind of tricks people sometimes because they're like, why is the -1 the one you're subtracting? Think about which area was larger, right? The orange area was larger. So even though it's like to the left on my graph, it's a smaller versus bigger type thing. Like how you used to learn to subtract before you knew that negative numbers existed. You were like, you're always subtracting from the bigger number. Later we learned that that's not always the case. Okay, so moving on, Brown. We can now sub in our values. 8413 minus the blue 1587. And when we subtract those, we end up getting 6826. Remember, we were trying to prove that it was 68%. So if we round that, that's 68%. Okay, so we have proven what we set out to prove. So QED. Latin for we have proven what we set out to prove. Okay, moving on. Now let's try looking back at the cats and what can we find out about some information about those distributions. So what percentage of Siamese cats have a weight that is less than what Sasha weighed? So in the pink there, I just have the key information that we had for that distribution. So the mean was 8, standard deviation was 1.9, Sasha was 13 pounds, and we already calculated Sasha's Z-score at 2.63. So now what we can do is we can actually use the chart to try and figure that out. So in order to communicate this, I want to communicate it first in terms of X, then convert to Z, then actually look it up in the chart. So what I'm trying to find is the probability that a weight, so an X value, is less than Sasha's weight, which was 13 pounds. Again, I don't have a chart that can look up every single normal curve. I only have a chart that can look up the standard normal curve, which is why we normalize it. That's why that's a term, to a Z-score. So the corresponding Z-score there was 2.63. So I've converted. It's kind of like the idea of converting like centimeters to meters, that kind of idea. Okay? From there, we're just going to look it up in the chart. So I know it's hard to see on the slides, but you guys have it hopefully printed out or you have a formula sheet. We're going to go down the positive side of the chart. We're going to look for 2.6, which is right there. And then we're going to go over to 3 hundredths. So 0 hundredths, 1 hundredths, 2 hundredths, 3 hundredths. So we end up getting 0.9957. So what that means is that 99.57% of Siamese cats weigh less than Sasha does. So she's really in the kind of extreme wing of that graph. Okay. We can also say she's in the 99th percentile. With percentiles, you always just round down, or that's kind of a weird term. You truncate the number just to the whole number of percent. So Sasha is in the 99th percentile for weight. Okay, so you can either write that as your conclusion, or you can just write your conclusion that 99.57% of all Siamese cats weigh less than Sasha. All right, now, sticking with this same distribution, actually, we didn't actually draw a sketch for this. We should always draw a sketch. So I am going to just kind of erase what we've drawn here so that we can fit our sketch, because I know it's underneath. Just say done. So our sketch, just going back, we have our scale for weights. And again, I'm pulling that kind of because we've already done this sketch, and this is just kind of to help us draw this particular situation. Our mean was 8, and our standard deviation was 1.9, so that's 3 standard deviations away. We also have our Z-score showing 3 standard deviations, and 0. And then we have our curve. So what I just calculated was, again, 13 is right here. What I just calculated was what percent is in this area. Again, sorry for going over my written work from before. Okay, so whenever you're doing a normal distribution problem, you should always include a sketch so that you can kind of plan out what's happening. Okay, moving on. So this one we have the sketch here, and we want to know greater than 11 pounds. So what I'm going to do is I am going to just draw where 11 pounds is on this. So that will be right there. I'm going all the way down to my Z-score too. So I know when I calculate my Z-score, it should be between 1 and 2, right? It wants to know greater than. So greater than is this area. But when I look it up in this chart, the chart only ever gives me the less than area. It gives me this section. Okay? So in order to get the green section, we're gonna have to do 1 minus, because the entire area is 1. So if I minus the total area minus the orange, that's gonna give me the green. Okay? Before I can actually look anything up in the chart though, I need the corresponding Z-score. So in order to get the Z-score, I am again going to do the X minus mean divided by the standard deviation. 11 pounds minus the mean of 8 divided by the standard deviation of 1. So that Z-score ends up being 1.58. My decimal didn't go. There we go. So now I can go through and I can use this to calculate my probability. So again, the green area, oops, I went ahead a slide. There we go. The green area for a probability that we're trying to find is the probability that X is greater than 11 pounds. Again, I can't look up the pounds one. I can only look up standard normal distribution. So what I did was I converted that to a z-score instead. Z greater than 1.58. Then we realized that we can't look up greater than. So what I have to end up doing is the total, which is 1, minus the orange area, which is probability that Z is less than 1.58. And then when we look that up in the chart, so 1.58, again, we're going down the positive side. Here's 1.5. And then to get to 8, we're going all the way over, second last one, because the last one is 9. And so that ends up being 0.9429. And then when I do that subtraction, it is going to give me the green area, 0.0571. So our conclusion can be, therefore, about 6% of cats, of Siamese cats, weigh more than 11 pounds. Okay, last one we're going to do is another one where we're looking in between 5 and 10. So again, first thing on my sketch I'm going to do is just mark off 5 and 10. So there's 5. You can see that z-score is going to be between -1 and 2. And then 10 pounds is going to be right here. So that z-score is going to be really close to 1, just a little bit over 1, if I've drawn that correctly. So I'm going to first actually calculate those two key z-scores. And there's 2 of them, so I'm going to use subscripts. So z1 is going to equal x1 minus the mean divided by the standard deviation. So z1 equals 5 minus 8 divided by the standard deviation of 1.9. So my current z value for that particular piece is -1. Can't read my information there. 1.05. Nope, -1.58. Sorry about that. Okay, I do a similar thing for Z2. Again, remember you should be pausing and trying to do this on your own and then watching the solutions. So this is x2 minus the mean divided by the standard deviation. x2 was 10 pounds minus 8 divided by 1.9. That gives me the 1.05. Okay. So now what we can do is we can actually go through and write this down in terms of probabilities. Now, some people actually do the z-score calculations right in their probability, and that's okay. And maybe I'll post a picture of how that looks as well. But this is kind of the easiest way when you're first learning, I think. So what I'm trying to find is this area right here. So I'm going to write all of that stuff in green. I am trying to find the probability that a weight is bigger than 5 and less than, I just wrote that greater than or equal to sign wrong. Oops. A weight is greater than 5 and less than 10. Okay. In order to do that, I had to convert to z's because I can't look up weights. I can only look up the standard normal distribution. So that was a z-score that was greater than -1.58 and less than 1.05. Okay. Now the problem is, though, I can't look up the betweens. So again, I have to section it off into 2 parts and do a subtraction. So the bigger part is going to be everything in orange here. That's going to be from the 1.05. So that's probability that z is less than 1.05. And then in order to find just the green, I'm going to subtract this blue section down here. And the blue section is the probability that z is less than -1.58. Just rewrite that so I can fit her in. 1.58, there we go. And that was negative. Okay, so then we look up those 2 values, and we end up getting, for the orange section, it's 0.8531. And for the blue section, it's 0.0571. Again, you're looking at the negative for that one. So the negative 1.58, we'd go down the negative side, 1.5, go over to the 8, and it's going to come from right there. Okay. Then we do the subtraction, and that gets us our final answer of 796. So that means 79.6% of Siamese cats weigh between 5 and 10 pounds. And there we go. So again, big idea, and the step order we kind of do here. First and foremost, we draw a sketch. Okay. Secondly, we need to find our key Z values. Third, we set up our probability in terms of the variable that we're talking about. So the X, whatever that is, convert it into our Z statement. Then depending on how much work there is, we got to do all of this piece. And that plan is going to be based on kind of what you've colored in inside here. So having highlighters when you're doing this type of work is really, really handy. I heavily suggest you have a couple different color highlighters with you. You'll notice I was using kind of an orange or a yellow and a blue because they combine to make green. So I was trying to make that little bit of a connection. Although I guess I didn't do the green overlapping where the yellow and blue was. But anyway, 3 different colors is helpful is what my main point is. And then obviously your concluding statement. But that's kind of the big idea to how you're working through these new types of problems. Okay, that's it.